Hello guys, in this video we are going to discuss about a new topic JFET, which is also called as JFET. JFET is a FET in which the gate is created by reverse bias junction. The abbreviation of JFET is junction field effect transistor. Let us see outline of JFET. They are field effect transistor, junction field effect transistor, construction of JFET, theory of operation, IV characteristic curve, pinch of voltage, saturation level, breakdown region, ohmic region, cutoff voltage, advantages, disadvantages and application of JFET. The ordinary or bipolar transistor has two main disadvantages. They are it has low input impedance and it has considerable noise level. In order to overcome this problem, the field effect transistor is introduced because it has high input impedance and low noise level than ordinary transistor. And junction field effect transistor is a type of field effect transistor. First, let us know about what is field effect transistor. Field effect transistor is a voltage controlled device. It consists of three terminals: gate, source, drain. And FET is classified into four types. They are JFET, MOSFET, MESFET, MISFET. Now let us see one of its type, JFET. As I mentioned above, JFET is the junction field effect transistor. Is a three-terminal semiconductor device in which current conducted by one type of carrier, that is by electron or hole. Construction of JFET, it consists of source, drain, gate, channel. Source, the terminal through which the majority carriers enter into the channel, is called the source terminal. It is denoted by S. Drain, the terminal through which the majority carriers leave from the channel, is called drain terminal. It is denoted by D. Gate, there are two internally connected heavily doped impurity regions to create two PN junctions. These impurity regions are called gate terminal. It is denoted by G. Channel, the region between the source and drain sandwiched between the two gates is called the channel. Types of JFET, there are two types: N-channel JFET, P-channel JFET. Here we can see symbol of N-channel JFET and P-channel JFET. Features of JFET. JFET is a voltage control device, that is input voltage VGS controls the output current ID. In JFET, the width of a junction is used to control the effective cross-sectional area of the channel through which current conduct. It is always operated with gate source PN junction in which reverse bias. Because of reverse bias, it has high input impedance. In JFET, the gate current is 0, that is IG is equal to 0. Theory of operation. When gate source voltage VGS is applied and drain source voltage is 0, that is VDS is equal to 0 voltage. When VGS is equal to 0 voltage, two depletion layer and channel are formed normally. When VGS increase negatively, that is 0 voltage greater than VGS off, depletion layer are also increased and channel will be decreased. When VGS is equal to VGS off, depletion layer will touch each other and channel will totally removed. So no current flow through the channel. Here we can see detailed diagram. When drain source voltage VDS is applied at constant gate source voltage VGS. Now reverse bias at the drain end is larger than source end, and so the depletion layer is wider at the drain end than source end. When VDS increases, that is 0 voltage lesser than VDS lesser than VP, depletion layer at drain end is gradually increased and drain current also increased. When VDS is equal to VP, the channel is effectively closed at drain end and it does not allow further increase of drain current. So the drain current will become constant. We can see the detailed diagram. IV characteristic curve. It is the curve between drain current ID and drain source voltage VDS for different gate source voltage VGS. It can be characterized as: for VGS is equal to 0V, the drain current is maximum. It is denoted as LDSS and called shortened gate drain current. If VGS increases, drain current ID decreases, ID lesser than IDSS, even though VDS is increased. When VGS reaches a certain value, the drain current will be decreased to 0. For different VGS, The ID will become the constant after pinch of voltage Vp through VDS is increased. Transfer characteristic curve. This curve shows the value of ID for a given value of VGS. The figure shows the transfer characteristic curve. Pinch of voltage Vp. It is the minimum drain source voltage at which the drain current essentially becomes constant. The graph shows the pinch of voltage. Saturation level. After pinch of voltage, the drain current becomes constant. This constant level is known as saturation level. The mark shows the saturation level in graph. Ohmic region. The region behind the pinch of voltage where the drain current increases rapidly is known as ohmic region. From the graph, the circled region is ohmic region. Breakdown region. It is the region when the drain source voltage VDS is high enough to cause the JFET resistive channel to break down and pass uncontrolled maximum current. From the graph, the shaded region is breakdown region. Cutoff voltage. The gate source voltage when the drain current becomes zero is called cutoff voltage, which is usually denoted as VGS off. From the graph, we can see it clearly. Advantages of JFET. It is simpler to fabricate, smaller in size. It has longer life and higher efficiency. It has high input impedance. It has negative temperature coefficient of resistance. It has high power gain. Disadvantages of JFET. Greater susceptibility to damage in its handling. JFET has low voltage gain. Finally, we come to the end part. Let us see application of JFET. Voltage controlled resistor, analog switch or gate, act as an amplifier, low noise amplifier, constant current source. These are the applications of JFET. I hope you all enjoyed and learned something new topic about JFET. Thanks for watching. Bye.